The OECD Halden reactor project, of which the Norwegian Institute for Atomenergy is the responsible operator, was established in 1958 and has throughout 14 years of international cooperation carried out major development programs in water reactor physics, dynamics, chemistry, in-core instrumentation technology, and computer control. Because of the increasing complexity of today's industrial processes, the more severe safety requirements and the need to improve the quality of control and supervision of these processes, the flow of information to the operator is steadily increasing. To explore the properties of a modern operator-process communication system in a practical environment, a computer and color display-based system was developed and investigated extensively at the Halden reactor project in Norway. It was used to build up an experimental control room adjacent to the conventional control room of the Halden reactor. For the operation of the Halden reactor, a number of supervision and control functions were implemented, which the reactor operator can control from the console. Both he and the plant supervisor can call up plant variables and their limits, change the limits, activate control loops, operate pumps, valves, and control rods, request trend curves, mimic diagrams, and so forth. For the display of plant information, the operator has at his disposal 3 color CRTs. The operator's console consists of function push buttons and alphanumeric displays built up from light-emitting diodes. For direct addressing on the CRT, a tracker ball moves a square mark on the screen. The 3 console windows display process variables and are also used for addressing and changing of parameters. In order to visualize the status of some plant circuits, the operator can request mimic diagrams with information on whether pumps are running or not, and circuits and valves are open or closed. By means of the tracker ball, the operator may request further information about water levels, temperatures, and pressures. To operate the control valves, the operator can address the proper valve directly by pushing buttons on the console. Notice how the mimic diagram follows changes in the process dynamically. For example, the valve symbol of the diagram and the lines it controls are changing color from red to green if the circuit is opened. The tracker ball is used extensively for the addressing of pumps and valves. Predefined push buttons on the console may then be used to start or stop the pumps and open or close the valves. For supervision of the process, a number of variables are logged for trend display. The operator can request 10-minute, 1-hour, and 24-hour trends. The 10-minute trend is regularly updated while shown on the screen. The scale along the ordinate axis is automatically adapted to give optimum resolution of the displayed variable. According to the different operating conditions of the plant, the operator has a need for observing different plant variables. This is the task of the group displays that are included in the system. Within normal operating limits, the bars following the actual plant variables are green, while blue and red colors are used to indicate operation outside the recommended or permitted limits. The maximum amount of process information which can be given simultaneously to the operator is much less in the CRT display-based control room than in the conventional control room. Therefore, an effective plant disturbance analysis system which checks input signals against limits and based on plant status selects proper messages for display is highly desirable. The operator can, by means of the tracker ball and the console, change the monitoring limits. This is visualized with the help of a display for each monitored variable. All routine control functions in this type of control rooms will be automated with the help of computers, which are better suited for such tasks than human beings. As a result, they will be manned by fewer operators than conventional control rooms. For control of some plant variables, the operator can set the individual loops in an automatic or manual mode of operation and change the set point. By means of a control program, the reactor power is adjusted and kept at set point. The operator can easily change control parameters such as the power set point, the controller deadband, and the control routes used for the control. The ramp control program automatically increases the reactor power to a specified level at a specified rate. Automatic repositioning of control routes is possible. The reactor supervisor, less active in direct reactor operations than the operators, is provided with a separate standard keyboard and a color CRT. He may request the same plant information as is available to the operator, but takes no active role in controlling the plant. Systems engineering of man-machine interfaces calls for a wide interdisciplinary knowledge covering various subjects such as technology, psychology, information theory, process theory, and so forth. The experiments performed at the Halden Reactor Project have been promising, and those planned are expected to give further valuable information on the performance of computer and color display-based control rooms.